Welcome to the third and final part of solving quadratic equations by graphing and factoring. In this video, we are going to focus on the special products and factors methods for factoring our quadratic equations. There are two different types of special products that, if we recognize them, can make factoring our quadratic functions a lot easier. Let's jump right in. Our first special product method is the difference of two squares, and I've shown a little method for it here. If a squared minus c squared occurs in your quadratic function, then we factor it down to a plus c and a minus c. What does this mean? If we have x squared minus 4, for instance, I have a perfect square over here, which is x squared, and I have a perfect square over here as my constant, which is 4. If both of these are perfect squares and we are subtracting them, I can then factor this down almost instantly to x plus 2 and x minus 2. And 2 is because the square root of 4 is 2. That is the difference of two squares. If we have, let's say, x squared minus 16. Once again, I have a perfect square with x squared. I have a perfect square with 16, and we are subtracting them. So this would become, x plus 4 and x minus 4. Now, you could also have 9x squared minus 25. Even though the 9 is here, 9 itself is also a perfect square to go along with the perfect square of x squared, and 25 is a perfect square. So we would factor this down to be 3x plus 5 and 3x minus 5. The 3 comes from the square root of 9. And lastly, let's see an example that would not work. Okay, if I were to have something like 5x squared minus, we'll go back to 36. I have subtraction. I have a perfect square with my constant, but 5 ruins it. 5 is not a perfect square. There are no two whole numbers that when multiplied give us 5. So we would have to use something else to figure out this factor. Alright, now that is method number 1, the difference of two squares. Now let's look at perfect square trinomials. For perfect square trinomials, we're going to have our typical standard form quadratic function, but I've written it a little bit differently here. Instead of b, I have 2ac. Now, when we are trying to use perfect square trinomials, the front term and the back term have to be perfect squares to start off with. So let's say I have x squared minus 10x plus 25. This is a candidate to use the perfect square trinomial method because the front term and the back term are perfect squares. When that happens, just like with our difference of two squares, we can start to condense this down as x minus 5 squared. But before we can commit to this being our answer, I need to make sure that this middle term is the result of 1x times 5 times 2. That's where the 2ac comes from. A was 1x, c was 5, the square root of 25, and if I multiply those together and double it, I need to get the middle term. If this was x squared minus 11x plus 25, I would not be able to use this special technique to factor it down. I would have to do something else. So we have to check that the front and back are perfect squares, and that the middle is 2 times the front square root times the back square root. Let's look at a different one. Let's say I have x squared plus 4x plus 4. This time I'm using the bottom equation because I have both additions. Well, I start with a perfect square, I end with a perfect square, so I will start by saying it is x plus 2 squared, and then to check is 2 times 1x doubled 4x, and it is. 2 times x is 2x, double that, we get 4x. And this will also work if we have something in front of the x that is a perfect square. So let's look at one of those to finish off this video. Alright, here we have 4x squared plus 4x plus 1. 4x squared is a perfect square, and believe it or not, 1 is also a perfect square because 1 times 1 equals 1. So I can start using my bottom perfect square trinomial again, since I have both addition signs. This is going to turn into 2x, because 2 is the square root of 4, plus 1 squared. And now I just have to do my check. 2x times 1 is 2x, double that, and we have 4x. And there is my factor, 2x plus 1 squared. Alright, we've done 3 parts to solving quadratic equations by graphing and factoring. Hopefully you found them useful, and good luck.